This is the lecture for section 4B, which is the power of compounding your interest. Before we can talk about compounding interest, we have to discuss a few definitions here. The principal in financial terms is the balance upon which the interest is paid. Simple interest is where interest is only paid on your original deposited amount. You will not earn interest on interest. Versus compound interest, which is where you earn interest on what you first put in and then all the continuous interest that you gain throughout the process of having this account. Most banks pay in compound interest, but there is a thing called a savings bond, which pays in simple interest. So let's say you invest $1,000 in a savings bond that is going to pay simple interest of 10% per year. How much total interest will you receive in 5 years? Well, if the bond was then paid with compound interest, would you receive more or less? And let's explain. So first example here is simple interest. The bond will receive simple interest, which means that it will receive 10% of the $1,000 every year. So 10% times $1,000, 0.10 times $1,000, you're going to get $100 of interest every year. That means in total, you would get $500 of interest over the 5 years. $100 year 1, $100 year 2, $100, 3, 4, and 5. Okay? With compound interest, you're going to get more than $500. And here's why. The first year would start the same. You'd get your 10% and you would have $1,000 plus your 100. So now your new balance is $1,100. So compound interest then calculates your new interest based on that new balance. So for here, the second interest payment will be 10% of our $1,100. And the second year, we're going to earn $110. And then the next year, you're going to earn a little bit more than that. So what's going to happen is compound interest is going to raise your balance faster than simple interest. So anytime you have a choice to do compound interest, you are going to gain more on your money with that option. The first formula we're going to look at here is compound interest if you only receive interest one time a year. So we have the amount in the account is going to equal the principal times the quantity 1 plus your annual percentage rate raised to however many years, that's your power. Again, this is going to be for interest that is calculated one time a year. As we go through this section, you will also see what happens if we compound it more frequently and how that formula is going to change. Suppose you can invest $100 in 2 accounts that each pay an interest rate of 10% per year. One is going to pay simple interest and the other is compound interest. Let's make a table to show the growth of each over that 5-year period. So here you're really going to be able to see that difference that happens between simple and compound. And then on the third slide of this problem, we're going to actually use the formula just to verify that the answer is the same as doing it in the table. All right, so on the left-hand side here, this table on the left-hand side is the simple interest. Simple interest is going to calculate the 10% on the initial investment, which was $100. So you will see here that every single time you do this, 10% of 100 is $10. So you'll earn $10 here, $10 the next year, $10 the third year, $10 the fourth year, $10 the fifth year. You will end with $150 if you use simple interest. Now, compound interest is a little different. It starts off the same, 10% of your balance, $10. You're going to add that and get a new balance of $110. That $110 is what you're going to use to calculate your next set of interest. So this time, the second year, I'm going to earn $11 in interest. Add that in. My new total is $121. My interest is now calculated on that value. So now I'm going to get $12.10. Add it in. Repeat this all the way through. So in the end, I am earning $161.05, which is $11.05 more than the simple interest. This is because the interest earned goes towards the new balance, and then the next set of interest is calculated on that new balance, not just the initial investment. The last thing they wanted us to do was verify that this works in the formula. So the amount in the account is equal to the principal, or $100, times 1 plus the APR. APR was 10%. We must write it as a decimal. So divided by 100 is 0.1. And then how many years it's sitting for is 5 years. So I will add 1 plus 0.1 gives me 1.1. I have 100 times 1.1 to the 5th power. You need to use a scientific calculator to type this in. The best one to use is Desmos. Please, if you have an iPhone, do not just use the basic calculator. It is not following the basic order of operations. You need to use a scientific calculator. So please go to desmos.com and you can type this in exactly as you see it, and you should get 161.05. If you are not getting that value, you're not using a scientific calculator, or you are not typing it in correctly. Here's how you would type this into Desmos. 100, open your little keyboard here, times, open parentheses, 1.1, close parentheses, and the power, you're going to hit this one here and type 5. And that is how I got the answer of 161.05. So these first two problems are going to be simple interest. We need to make sure we read carefully to know which method we're using. How much money would be in an account earning simple interest if you deposit $800 in an account earning 5% for 5 years? Remember that simple interest is going to be the same interest every single year. So I'm going to calculate one set of interest, $800 times 5%, 0.05. That gives me $40 of interest per year. Now I'm going to get $40 per year for 5 years. So then I want to times that by 5 years. And my total interest I'm going to earn is $200 in interest. If I add that to my initial $800, I will have $1,000 in the account after 5 years. How much money would be in an account earning simple interest if you deposit $3,200 in an account earning 3.5% for 10 years? Again, simple interest. You have to make sure you're reading the word. Is it simple or compound? So simple means you're going to find the first interest, and that's going to be the same interest every year. 3.5% is 0.035. Times it by 3,200, I'm going to get $112 per year. And that's going to happen 10 years. So I'm going to times that by 10 years. And that means my total interest is going to be $1,120. If I add that to my initial amount that is in the account, I will have a total of $4,320. These next ones say compound interest. Find the balance in the account compounding annually. So now we have to use that formula. $5,000 invested at 4% for 10 years. and $10,000 invested at 3.7% for 12 years. So this first one, we're going to take 5,000 times 1 plus your rate, 0.044% is 0.04. You can always divide it by 100. We're going to raise that to the 10th power. I can go to a scientific calculator and I should get $7,401.22. I will show you that in just a second here. The second one is $10,000. 1 plus 3.7% is 0.037, and we want to do that to the 12th power for 12 years. This one should give $15,464.83. Again, I will show this in the next slide here of how you can enter these in Desmos. This first one that we did was 5,000, open parentheses, 1 plus 0.04. The other way to do a power is shift 6. That'll raise you to the power, and we get the exact same value, $7,401.22. And the second one was 10,000, open parentheses, 1 plus 0.037, raised to the 12th power, and that is the same answer we got, $15,464.83. So always follow proper rounding rules. 5 or more, you're going to round up. So this one rounded, the 7 rounded to 2 to a 3. This one, 1 does not round. Now, we don't have to just get interest compounded once a year. A lot of times what happens is at the bank, we get interest every month. So what I'm going to show you here is the difference between compounding quarterly, in this case, which is 4 times a year, versus 1 time a year. So in this table here, we've got $1,000 and we're going to get 8% per year, but we want to do it quarterly. So if it's 8% per year, quarters, there are 4 quarters in a year. So 8% divided by 4 means I'm going to get 2% every quarter. So we're going to follow that process. 2% of my previous balance gives me $20. Add it to my balance. That's what I have after the first quarter. Now I'm going to calculate interest on that. So 2% of that balance gives me $20.40. Add it to the previous balance. I'm now at $1,040.40. Calculate the interest on that balance. Gives me $20.81 this time. Add them together to find my balance. I'm just going to repeat this process one more time here. 2% of the previous balance, I now get $21.22 interest. Add that to the previous balance, and I get $1,082.43. So that is compounded quarterly. Had I just done it 1 time a year, it would have been 1,000 times 1.08 to the 1 year. I just want to see that value. And that gives me this value down here, 1,080. So I earned slightly more money. It may only be $2.43, but the rule is the more you compound your interest, the more money you will end up with. This is now the formula for compounding interest more than once a year. So you'll see now that there is this N added in here, and N represents the number of times in the year that we're going to get that interest. So quarterly would be 4, monthly would be 12, weekly 52 weeks in a year, daily 365. And then this power up here has now changed to how many times a year times the number of years. So now let's compare yearly with monthly. Suppose you deposit $5,000 in a bank account that pays an annual percentage rate of 3% and compounds interest monthly. How much money will you have after those 5 years? And then compare this amount to the amount you would have had if you only got it once a year. So just looking at what we have here, the initial investment, $500. Interest rate is 0.03. Monthly compounding means that we're going to get interest paid over 12 times of a year. And we are considering a period of 5 years. Plugging all those values into the formula, 5,000 times 1 plus the rate, 0.03, over 12 is going to be raised to the 12 times 5 power. We can simplify a little bit here if you want to. 5,000 times, we can do this addition here. The 1 plus 0.03 over 12 is going to give me 1.0025. And the power simplifies 12 times 5 is 60. We could then go to our scientific calculator and you're going to get $5,808.08 is the amount in your account after those 5 years. If we only did interest once a year, we would go back to the initial formula we saw, not dividing by n here. You'll see that's 5,000 times the quantity, 1 plus 0.03 to the 5th power. And this one will yield us $5,796.37. So again, we've shown that the more frequently you get for interest, the more money you're going to earn. This shows how you could type the original problem in Desmos, again, as long as you make it look exactly like how you wrote it for the formula, you will see that you get that same answer had I simplified it. After 5 years, we had that value of monthly compounding, $5,808.08, versus annual was $5,796.37. So we could subtract those two to calculate the difference in amount of money. And it may only be $11.71, but if you are investing larger and larger amounts of money, that difference is going to actually be a lot greater. And again, you're going to always want to look for those accounts that compound more frequently versus simple compounding or just once a year. Now, I understand that not everybody likes formulas and struggles in math, so sometimes the formulas are a little frustrating or hard to follow. So what I have done is throughout the class, if there is a website that can do these calculations for us a little bit easier, I'm going to share those with you. So right here, I have 2 calculators. One is going to give us the future value, which was what we've just been finding. And then I'm also going to give you the one that finds present value. So that situation is when you want to have a certain amount in the future, what do I need to deposit today? So let's take a look at these calculators and we'll do some examples. All right, so here is the future value calculator. And let's see how we would do that with these problems. Find the amount in the account if $4,000 is invested for 5 years with an annual percentage rate of 3% compounded quarterly. So the first thing it has us do is type the number of years, which is 5. Then it has us type the interest rate, which is 3. It then has us select how it is compounded. You have daily, monthly, quarterly, or yearly. And your initial investment is $4,000. And then you're going to click calculate. And you'll see right here, this is the value, the future value of the account, $4,646.47. I'm going to write that answer in here for us. So $4,646.47. Let's do the next one. $30,000 is invested. So that's my initial investment, $30,000. for 15 years. Like 15. Oops. Interest rate this time is 4%, 4.5%, and it wants daily. So I'm going to click daily, and then click compute. And this one here is going to give us a final value for 15 years of $58,918.54. The next set of problems we're going to look at here is present value. So let me open that calculator. And again, this is one that wants us to go the other way. So the question is going to sound a little different. How much would you have to deposit today to have $25,000 in 8 years for a down payment if the account compounds quarterly with an APR of 6%? It's going to look similar. Number of years, 8. Interest rate is 6%. Compounding quarterly. And we want to have $25,000. Now, future value should always be more than your present value because future is what you're going to have in the future. If I calculate this, it says to have this goal, I would need to deposit $15,488.10 today to meet my goal. And then we can do this last one here. How much must you deposit today into an account to have $120,000 in a college fund in 15 years if you have an APR of 5.5% compounded daily? I have 15 years, 5.5%. We're going to go daily, and I want to reach 120,000. All right, so what I would need today would be $52,591.47. So if you look at this, to go from 52,000 to 120,000, I am gaining just by letting my money sit there. Let's see if I do that subtraction. 120,000 minus 52,591.47. I am gaining $67,408 just in interest from letting my money sit there. So this is why starting investments early, the right investments, compounding, you can have a decent amount of money for retirement in your future. This is the end of section 4E. The end of what you have to watch for week 3. So please go on and do the homework for this section from Pearson, as well as your discussion board, and meet me back here next